Okay, guys, we're going to do the check your understanding on page 389. Okay. For each of the following situations, determine whether the given random variable has a binomial distribution or not, and justify your answer. Okay, binomial, remember we have to look for, we do our little acronym BINS, okay? I'll go through them all. We're going to shuffle a deck of cards, turn over the top card, put the card back in the deck, and shuffle again. Repeat this process 10 times. Let X equal the number of aces you observed. Okay, so for the binomial, there's binary outcomes. There's a success. In this case, the success is we get an ace, and there's a failure, which is not an ace. Okay? I stands for independent. Is each card independent of the other? Yes, it is, because we put the cards back. Okay? Well, actually, yeah, because we put the cards back. So each card is independent, okay, because of replacement. Well, that's more probability anyway. N is a set number of trials. Indeed, we're going to do 10. We're going to pick 10 cards. There's a set number of trials, and S is the probability of success has to be the same. So is the probability of success the same every single time? The probability of getting an ace is what? 4 out of 52, right? There's 4 aces in a deck of 52. So it is the same every single time because of replacement. So we will say that this is binomial, okay? Yes, this is binomial, so we will say it's a binomial distribution with 10 trials, and probability of success is 4 over 52. So this is just like we would do normal with the mean and the standard deviation. We do binomial with the set number of trials and the probability. Okay? Okay, number 2 scenario says, choose a student at random from your class. Let Y be the number who are over 6 feet tall. Okay, are there 2 outcomes? Binary, two outcomes, it's binary, so we have a success that they're over 6 feet tall, and the failure is that they're not. Okay? Is each person independent of the other? Each student is independent, but we'll talk about that when we get to the probability. Is there a set number of trials? It just says choose students at random from your class. So there are no set number of trials. Okay? So that's not satisfied. And then is the probability of selecting a student that is 6 feet tall the same? The probability is not the same because of non-replacement. We didn't pick somebody and then it didn't say stick them back in the group. Okay, so this one is not binomial. Okay. Okay, number 3 over here. Roll a fair die 100 times. Sometime during the 100 rolls, one corner of the die chips off. So let W be the number of 5s you roll. Okay, so our success is we roll a 5, and our failure is we don't roll a 5. Is each roll independent? Yeah, each roll is independent of the other roll. Dice don't remember and they don't impact each other. Is there a set number of trials? Yeah, it's said to roll 100 rolls. That's a set number. And is the probability the same? Is the probability of rolling a 5 the same? No, because the dice chipped somewhere along those 100 rolls. So that chip is going to cause the probability will change. The probability will not be consistent, or will change. Who knows what that chip's going to do? It could make the 5 higher probability rolling a 5 or a smaller probability rolling a 5, but it isn't consistent throughout the whole 100 rolls. So this one again is no, not a binary.